Listen here. In the last class, we have begun a new lesson, that is metals and non-metals. So, we discussed about the physical properties of metals and non-metals. And also we discussed about what happens when a metal reacts with oxygen or air. So, when metal reacts with oxygen, what is going to produce? Metal oxide. Then, what happens when metal reacts with water? So these two concepts we discussed in the last class. And also we discussed about the very important definition. Very important definition. What are amphoteric oxides? When metal oxides reacts with acid and base, reacts with metal or non-metal, or acids or bases? Acids and or bases to produce salt and water. Example, aluminum oxide, zinc oxide. Okay, and also we discussed about the what happens when metals reacts with water. Today we are going to discuss about how does a metal reacts with the acids. How does metals react with acids? How does metals react with acids? How does metal react with acids? So what is the general statement? How does a metal reacts with acids? I think already we have discussed in the second chapter. Acids, bases and salts. So acids, what is the product it is going to give when a metal reacts with acid? It is going to produce salt plus hydrogen gas. This is general statement. That how does or what happens when metal reacts with acid. Any metal react with acid, it is going to give or it is going to produce salt and hydrogen gas. Okay, so you listen here. Metals, in your book they given so many examples. For example, first example they given, that is a magnesium. So what is the symbol of magnesium? Mg. Plus acid, you take any acid, we shall take HCl, hydrochloric acid. It is going to produce salt, that is MgCl2. Plus, along with that, it is going to produce hydrogen gas. Suppose metals reacts with acid, it is going to produce salts. Metals react with acid, it is going to produce salts and hydrogen gas. This is our example. So, can you balance the equation? Mg, H here 1, H 2. Then Cl2. So, once again, Mg, 2H, then 2L, then Cl is also. Okay. So, this is an example. Like that, another example, and another example that is given in a book. Second example. Then aluminium is another example they given. Aluminium symbol Al. Aluminium reacts with HCl. Give rise to AgAlCl3 plus H2. Then balance the equation. Al here, H is here 1, there 2, So shall I put here 2? Then here Cl is also 2, but here Cl is 3. So to make it here also 3, I will put here 6. Then here 2, here 3. Al2, then H6, 3 2s are 6, Cl 6, 2 3s are 6. So this is another example for, so in this 2 example, we are going to see here when a metal react with acid, it is going to produce salt. These are the salts. Along with the salt, it is going to produce hydrogen gas. Okay, so this is the examples. But in our book, they give another example, that is iron. Iron reacts with HCl, Fe, Cl, 3, 2, then H2, Fe, H, here 2, here only 1, so I will try to make it 2, but Cl is 3, so for that I will put 6. So here then Cl 2 3s are 6, Fe 2, then H 3 H2. So this is another example. Most of the metals are going to react with acid, that is going to produce salt and hydrogen gas. But there is a exceptional case. What happens when a metal reacts with nitric acid? What is the formula for nitric acid? HNO3. HNO3, nitric acid. For example, but here it is acid. You take any metal. Suppose any metal reacts with this nitric acid, it does not produce hydrogen gas. So this is one of the repeated question. Why nitric acid is not to liberate, is not going to liberate hydrogen gas? It is a strong or good oxidizing agent, so it is going to produce water. It readily combines with hydrogen, oxygen. It is a good oxidizing agent. So it is going to produce H, but along with that, it is going to combine with O and it is going to form water. So if you want to produce hydrogen gas, we have to dilute the nitric acid. We have to dilute nitric acid in a very low concentration. Then we are going to get the hydrogen gas. So this is another example. So it is a strong oxidizing agent. That's why it is not going to produce hydrogen gas. So important, very, very important for your examination. Then next, we are going to discuss about, already in the first chapter, we have discussed about the displacement reaction. So what happens when a metals react with other metals? So it is going to make the displacement reaction. For example, in the first chapter itself, we have discussed about the displacement reaction. What is displacement reaction? Displacement reaction. Displacement reaction is a type of reaction in which more reactive element displace the less reactive element from the compound or solution. Okay, so here also the given example. So common example, that is if you are going to take the iron reacts with copper sulfate. Iron reacts with copper sulfate. It is going to produce FeSO4 along with that C. So in this example, we are going to see that here iron is more reactive element than the copper. That's why iron is going to displace the copper. You can see here, observe here. Here CuSO4 is going to become FeSO4, FeSO4 and displace the copper. So already we have discussed in detail about this concept displacement reaction in the first chapter. So here based on that they given a reactivity series. So this is very, very important for your examination. In the examination you have to write definitely there will be one question based on this reactivity series. So they given metals. 13 metals they are given. So it should be they given in the order of their reactivity series. So first one, potassium. Potassium is the most reactive metal. Then sodium. Then calcium. Then magnesium. Aluminium, zinc, Fe, then Pb, lead, Pb, over, then hydrogen, then copper, then Hg, and then Ag and A. So this is the reactivity series. Sodium, first one, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, then copper, then mercury, silver, and then gold. So it should be written in the order. So based on this, in the examination, they are going to ask the question, for example, which comes after the aluminium, which metal come in the reactivity series, which metal comes after aluminium. Okay, like that they are going to ask. Otherwise they are going to give 3 metals. So write in the increasing order or decreasing order of their reactivity series. Like that they are going to ask the question based on this reactivity series. So here, after this reactivity series, we are going to discuss later on. We are going to discuss this reactivity series in the extraction of metals. The extraction of metals. So another important concept that is what happens when metals react with the non-metal. So next concept, what happens when metals reacts with non-metals. What happens when a metal reacts with a non-metal? So when a metal reacts with a non-metal, it produces a compound called ionic compounds. It's going to produce a compound called ionic compounds. So what is the definition of this ionic compounds? Here, transfer of electrons from metal to non-metal. Transfer of electron from metal to non-metal is called ionic compounds. For example, for ionic compound, example NaCl or MgCl2. So in your book they given example for this NaCl and MgCl2. So these are 2 examples. So let us recall what is ionic compound. Transfer of electrons from metal to non-metal. In this example, NaCl, which is the metal? Na is the metal, Cl is the non-metal. In the magnesium chloride, Mg and then Cl. Okay, so this is the example for this ionic compounds. Okay, so next. So here in your book they are given two examples. First one, NaCl. Explain the formation of NaCl. Formation of NaCl. So how to write the ionic compound for NaCl. So for this, first we have to write the NaCl, Na and then Cl. What is the number of atomic number of sodium? Sodium atomic number is 11. If you write the electronic configuration for this sodium, 2, 8, 1, and then here 17, atomic number is 17. So here 2, 8, 7. Okay, so here if you are going to write the formation of ionic compound for NaCl, so here in the outermost shell only one electron is present. In the Cl there are 7 electrons. So you know that the property of metals have a tendency to donate electrons. So sodium is a metal. This is going to donate 1 electron to the chlorine. That is a non-metal. So that is the definition of NaCl. That is the definition of the ionic compound. That is a definition of ionic compound. Transfer of electron from metal. So this is a metal. Transfer of electron from metal to Cl is the non-metal. So how we are going to show this? Here for example, NaCl. I am going to write here Na, then Cl. In the outermost shell, how many electrons are there? Only 1 electron. Then in the Cl, 7. Always electrons are in pair. They are in a pair. For example, here in the outermost shell, there are 7 electrons. So here 1, 2, 3, 4, 5, then 6. By 7, 2, 4, 6, and then 7. Okay. So here 1 electron from sodium is transferred into chlorine. So then it is going to become NaCl. Now, in the same way, we are going to find this MgCl. Mg, atomic number 12, chlorine 17. Here Mg 2, 8, 2. Chlorine 2, 8, 7. Okay, so here, how does this 2 outermost shell, that is 2 electrons are going to be transferred into chlorine. So here for this, I am going to write here Mg.
So you can write Cl2 against Cl again.
Oh, I can write Cl17, 2, 8, 7. So Mg is there. Then how many Cl are there? 2 Cl are there. So I am going to write here one Cl, another Cl here. So electrons in Mg, outermost shell, there are 2 electrons. 1, 2. In the Cl, there are 7 electrons. Here 1, 2, 3, 4, 5, 6, and then 7. Here also 7. 1, 2, 3, 4, 5, 6, and then 7. So here, one electron is going to transfer into this Cl, another electron is transferred into this Cl, and it is going to form MgCl2. So, like this, it is going to form the ionic compounds. Out of these two, definitely there will be a one for your examination. Okay, so this is the two examples they given in your book. Explain how the formation of ionic compounds are formed in the NaCl as well as in MgCl2. Okay, next, physical properties of this ionic compounds. Physical properties of ionic compounds. Physical properties of ionic compounds. So there are 4 physical properties of ionic compounds are there. First one, that is a physical nature. This is the first one, physical nature. Second property, melting point and boiling point. Third property, solubility. Fourth one, conduction of electricity. So this is also a very important question. Then most repeated question, write the properties of ionic compounds. Write the properties of ionic compounds. So first one, physical nature. Second one, melting point and boiling point. Third one, solubility. Fourth one, conduction of electricity. So first one, physical nature. You know that usually ionic compounds are solid. Usually ionic compounds are solid. Why they are solid? So in the ionic compound, there is a strong force of attraction between the ions. Strong force of attraction between the ions. So you know about the ions. Ions. What are ions? What are ions?
Which has tendency to share electrons.
What are ions? Charged particles are called ions. Charged particles are called ions. There are 2 types of ions. You know that? Cation, another one, anion. Cation and anion. So what are cation? Cation means positively charged particles are called cations. Negatively charged particles are called anions. So this is the ions. So here in the physical nature, why ionic compounds are solid? Give reasons. In the give reason, they are going to ask generally ionic compounds are solid. So for that answer, why they are solid? Because there is a strong force of attraction between the ions, that is a positive and the negative ions. So that's why they are solid, but they are brittle. If you are going to apply the pressure, it is going to break down. So this is the first property we have to know, the physical nature. Then second one, here generally the melting point and the boiling point. Ionic compounds are having high melting point and boiling point. So that means why in the give reason they are going to ask why ionic compounds have high melting point and boiling point. So here you know that as I told you here, there is strong force of attraction to break this strong force of attraction, we required high melting point and the boiling point. So, because of this, because to break the strong force of attraction, we required the high melting point and boiling point. So, in your book, they given a table for ionic compounds, 3 or 4 ionic compounds they given, and they given the melting point and the boiling point. Then solubility. So ionic compounds are soluble in water, but they are insoluble in organic solvent. They are insoluble in organic solvent. ಯಾವ್ದು organic solvents? ಕೆರೋಸಿನ್, ಆಲ್ಕೋಹಾಲ್, ದೇ ಆರ್ ಇನ್ಸಾಲ್ಯುಬಲ್ ಇನ್ ಆಯಿಲ್ಸ್ ಅಲ್ಲಿ ಏನಾಗಿರ್ತದಪ್ಪ, ಇನ್ಸಾಲ್ಯುಬಲ್ ಆಗಿರ್ತವೆ. ದೆನ್ ಲಾಸ್ಟ್ ಒನ್, ಕಂಡಕ್ಟಿವಿಟಿ ಆರ್ ಕಂಡಕ್ಷನ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ. Ionic compounds are generally they are a good conductor of electricity in aqueous solution. But in a solid state, they are bad conductor of electricity. Why they are bad conductor of electricity in solid state? So in the solid state, there will not be a exchange of ions. There is no movement of ions or exchange of ions. So there will not be a passing of ions, and that is going to pass the electricity. So these are the 4 important properties of ionic compounds. So what are ionic compounds, and then examples for ionic, 2 examples, that is NaCl and the MgCl2, example formation of ionic compound, and then physical properties of ionic compound. That is the physical properties. These are the physical properties. Definitely out of these 4, they are going to ask the give reasons, and as well as examination, write any 2 physical properties of ionic compound. Like that, they are going to ask the question. Okay, this is about the ionic compounds. And then after this concept, next concept, that is occurrence of metal. So as you know that all the metals are not going to occur in the nature as a metal. They are going to occur in the form of ores or in the form of minerals. So here in their book they given how we are going to extract the metals. So here in the reactivity series, we are going to divide in the metals into high reactivity metals, medium reactivity metals, and low reactivity metals. Okay, next class we are going to discuss about the how we are going to extract the low reactivity series, middle reactivity series, and the high reactivity series.